Question number 17 from section 4.2, we have an equation. X to the 7 over 3 power equals negative 128. Now this one's a little bit different than all those previous ones where you could write both sides using the same base. It's actually not an exponential equation. It is an equation where the base is x, so there's really no way that you can write both sides using the same base. So the key in doing these is to get x by itself. If this is x to the 7/3, 7 over 3 power equals negative 128, what you can do to get x by itself is to raise both sides to a power that will end up dividing out with this power. Since this power is 7 over 3, we're going to multiply, or actually raise it to the 3 over 7 power. And whatever you do to the left side, you're going to do the same thing to the right side. So x to the 7/3 to the 3/7 power equals negative 128 to the 3 over 7 power. You choose a power that is a reciprocal of the power given so that you can end up dividing those out. Remember, a power to a power, if you have a to the m to the nth power, it's a to the m times n. So this left side is going to be x to the 7/3 times 3/7. That ends up being a 1 when you multiply 7 over 3 times 3 over 7. You get x to the first power. And on the right side, you're going to have to use a calculator to get a decimal answer. So it's going to be negative 128 to the 3 over 7th power. And if you use a calculator, we can round that. I wonder if we can write that as exact, but let's check with a calculator first. In parentheses, I'm going to put in negative 128, raise it to a power that is a fraction, 3 over 7. Now you can use a scientific or graphing calculator for this to simplify to get negative 8 as the answer. Okay, again, the key to getting the x by itself here is to raise both sides to a power that is the reciprocal. And we can check our answer, negative 8. It looks like the last three problems are they're word problems. This one, number 18, suppose that $40,000 is invested at 9% interest per year. Find the amount of money in the account after 4 years if the interest is compounded annually. Find the amount of money in the account after 4 years if the interest is compounded continuously. If it's compounded continuously or compounded annually, we have to choose one of the formulas to use. This first formula is if you, for compounded interest, if it's compounded monthly, yearly, annually, semi-weekly, weekly, daily, any of those types of compounding periods, you're going to use the first formula. A equals P times the quantity 1 plus R over N raised to the NT power. Now, if it's compounded continuously, we are going to use the A equals PE to the RT power. You may have seen that in a finance class. These are two formulas that are used for compounding interest. Well, A is the accumulated value or the future value. P is the present value or the principal. R is going to be the rate written as a decimal. N is the number of compounding periods. And T is the time. So A, since the first one, we want to find the money in the account if it's compounded annually. So we have a lot of numbers here. We're going to look at the numbers and decide what letters those represent in our formula. The first number I see is this 40,000. 40,000 is invested. So that means our principal, our present value, P, is equal to 40,000. The next number I see is 9%. That's your interest rate, but you want to write the interest rate as a decimal. R equals 9% is the same thing as 0.09. The next number I see in the problem is 4 years. That's your time. You're going to keep 40,000 in a bank account for 4 years, and if it earns 9% interest, that money's going to grow. This next thing is going to determine the number of compounding periods in a year. This one, it says it's compounded annually. If it's compounded annually, the number of compounding periods in a year is 1. At the end of the year, interest is calculated, and then it will compound on that every year. The interest will accumulate. Since we have these values, we can plug it into the formula for A, which is equal to P times 1 plus R over N raised to the NT power. You definitely need a calculator, scientific or graphing, either one. A is the future value. That's what we're searching for. How much money is going to be there at the end of that time of 4 years? P is the present value, $40,000 times 1 plus R. The interest rate is 0.09 divided by N, the number of compounding periods. If it's annually, that's 1 compounding period. And the exponent is N times T. It's going to be 1 times 4. Using a calculator, you can simplify this and get the result. We're going to take $40,000 in parentheses 1 plus 0.09 divided by 1, close the parentheses, then you're going to raise this. So now you like to put this next part in parentheses, 1 times 4 exponent. Okay, so we have 40,000 times 1 plus 0.09 divided by 1, all of that raised to the 1 times 4 power. Now you can also simplify those first, and if you take 1 plus 0.09, that's going to be 1 plus 0.09, 1.09, raise it to the 1 times 4 power, which is 4. So either way you do that, just be careful making sure you do all the right calculations. The amount that's going to be in the account at the end of those 4 years, if it's compounded annually, $40,000 grows to $56,463.26. If you can get 9%, earn 9% interest per year compounded annually, that's your amount after just 4 years. And I'm rounding to the nearest cent here because with money, it would make sense to round to the nearest cent, not like 3 decimals or 4 decimals. This question has a second part. Okay, for the second part, we're asked to find the amount of money in the account after 4 years if the interest is compounded continuously. Now, if the rates are the same, it's really better to have continuous compounding for your interest if you're earning interest on your money. When you use the compounded continuously, you're going to use the A equals PE to the RT. A equals PE to the RT power. And from the first part of this problem, it's 40,000 times e to the r 0.09 times 4. I like to put parentheses around that whole exponent. You want to do that when you're using a calculator. Now the E button on the calculator is found. I'll show you where that is. $40,000 to start off with. And then the E button is right here on the graphing calculator, or above this button that says LN. It's a little E to the X button. I'm going to press second E to the X, and then I like to put parentheses around the exponent, 0.09 times 4, close the parentheses. Okay, try that with your calculator. You really want to make sure you know where that E button is on the graphing calculator. Now, E is a number that's used in science, and it ends up working out as this compounded interest formula. We can use this letter E. E is like the letter pi. Pi is 3.14159. E, on the other hand, is, if we just do E, say, to the first power, E by itself is 2.718. This is a number that's used in the science classes all the time. So instead of having to write out this big long decimal, our calculator is built in the value of E, and we can plug that into our formula. So the amount of money after 4 years is $57,000. $57,000, $333, and if we round it to 18 cents. And check your answer. Okay, you may notice something here that it's better if you have it compounded continuously because you end up with more money at the end of 4 years. 56,463 compared to 57,333. It's almost $1,000 difference. So if you're concerned about saving money and you have the option between annual compounding or continuous compounding, if the rates are the same, you should definitely go for the continuous compounding.